Next topic is electric field intensity at a point on the equatorial line of an electric dipole. So here we have to consider an electric dipole. AB is an electric dipole. The charge of the electric dipole is Q and the length of the dipole is 2A. So here we have to take a point O at a distance R from the center of the dipole. The point O is along the equatorial line of an electric dipole. So C to O, the distance is taken as R. A to C, the distance is A, and similarly B to C, the distance is A. Here E1 represents the direction of electric field due to the positive charge, and E2 represents the direction of electric field due to the negative charge. So next our aim is we have to calculate the distance AO. Using Pythagoras theorem, we have to write AO square, which is equal to A square plus R square. So AO is equal to square root of A square plus R square. Here the distance from A to O is root of A square plus R square. And similarly, the distance from B to O is also root of A square plus R square. Okay, so the next one, electric field intensity at the point O due to the charge plus Q can be written as E1 is equal to Q by 4 pi epsilon 0 into root of A square plus R square the whole square. If we take the square value, we get E1 is equal to Q by 4 pi epsilon 0 into A square plus R square. At the point O, the electric field intensity due to the positive charge can be split up into two components. One is along the x-axis and another one is along the y-axis. X-axis, the component which is always equal to E1 cos theta, and y-axis, the component which is equal to E1 sin theta. Therefore, E1 cos theta, which is along the direction OX, and E1 sin theta, which is along the direction OY. And next we have to write the electric field intensity at the point O due to the negative charge. E2 is equal to Q by 4 pi epsilon 0 into square root of A square plus R square the whole square. The same equation we can write E2 is equal to Q by 4 pi epsilon 0 into A square plus R square. The electric field intensity at the point O is split up into two components. That is E2 cos theta, which is along the direction OX itself, but at the same time E2 sin theta, which is along the direction OC. So the next step we have to calculate the resultant electric field. The resultant electric field is only along the direction OX. So here E is equal to E1 cos theta plus E2 cos theta. Here the sign components are cancelled. The reason is E1 sin theta, which is along the direction OY, and E2 sin theta along the direction OC. And here we know that the magnitude of E1, which is always equal to magnitude of E2. So that the sine components cancel, only the cos components are there, so it can be added up. So according to this condition, E1 is equal to E2, we can write the resultant electric field E is equal to 2 times E1 into cos theta. And next, one more important thing is the direction of electric field is along O to X, but the direction of dipole moment is from B to A. Direction of dipole moment is from the negative charge to the positive charge. Therefore, the resultant electric field E is equal to minus 2 into E1 into cos theta. Next, we have to substitute the value. E is equal to minus 2 into Q by 4 pi epsilon 0 into R square plus A square. And the next our aim is, here one term, that is cos theta. We have to calculate the value of cos theta to consider the triangle AOC. That is, in triangle AOC, we can take cos theta is equal to adjacent side by hypotenuse. Therefore, cos theta can be written as A by square root of A square plus R square. We can substitute here. A by root of A square plus R square, we can write A square plus R square the whole raised to 1 by 2. And the next we know this equation, Q into 2A, that is equal to P, which is the dipole moment. So we can write E is equal to minus P the whole divided by 4 pi epsilon 0 into R square plus A square the whole raised to 3 by 2. Here the power is 1, here the power is 1 by 2. So 1 plus 1 by 2, when we simplify, we will get the answer 3 by 2. Therefore, E is equal to minus P by 4 pi epsilon 0 R square plus A square the whole raised to 3 by 2. And next we have to consider, if the distance R is too much greater than A, then we can write E is equal to minus P by 4 pi epsilon 0 R square the whole raised to 3 by 2. Here we are neglecting the value A square. A square can be neglected. So here 2 and 2 cancel. So we get the value electric field intensity E is equal to minus P by 4 pi epsilon 0 R cube. This is the electric field intensity along the equatorial line of an electric dipole.
If you found this video helpful, please like, share and subscribe to the channel. See you in next class.